Center for Teaching and Learning Professional Development presents Asking Good Questions. This video will demonstrate questioning strategies using Bloom's taxonomy as the foundation. The purpose of this training video is to support teachers as they foster the development of problem-solving and critical thinking skills in their students. Asking students questions is easy. The real difficulty is in asking questions that foster learning and increase the student's ability to think and problem solve. By using Bloom's taxonomy of learning as a scaffold, the teacher is able to build successively more difficult questions, moving the student to complex thinking. The 6 levels of Bloom's taxonomy are: remembering, that's the recall of knowledge or information; understanding, comprehension of information and able to state it in their own words; applying, using information to apply to a new situation either in the lab setting or in real life; analyzing, determining the difference between facts and inferences; evaluating, making judgments about the material or ideas; and creating new meanings, processes, or structures. Each category is specific to one type of learning. These categories build on one another, moving from simple to more complex. When teachers question students, it's important to move the students beyond rote memory of facts and support their thinking process to ensure they understand the material, can apply the knowledge to real situations, are able to analyze and evaluate the situation, and make adjustments as necessary. It's also critical that students have a depth of understanding so that they can move beyond their current situation into creation of new processes or adaptation for future scenarios. The first level of Bloom's taxonomy of learning is remembering. Remembering questions are focused on students' ability to recall memorized data or information. This is rote learning. These questions start with words like define, how, what, when, where, name, match, recall, select, etc. Remembering questions are necessary to determine if the student has the basic information on board.
Okay, Lars, I'm ready to demonstrate my circuit.
Excellent. Give me a demo on how it works.
Okay, I'll show you on the board. So when the fluid level lowers, the lower float switch closes.
Great.
And the pump motor turns on and the relay coil is energized. When the fluid level rises again, the lower float switch opens and the signal that originally turned on the pump motor is no longer there.
What would you use to keep that signal present?
I would use a holding circuit.
Can you draw it for me?
Yeah.
Where would you put it?
Normally open contact of the relay in parallel with the lower float switch.
Excellent. And what's driving that?
It would be that relay over there. When this relay is energized, the contacts will close and it creates the holding circuit.
Excellent. What else can we do with relays to create logic?
We can use relays to reverse the signal, count a number of events,
Good.
or also control a sequence of events.
Excellent. Sounds like you got a good concept on relay logic.
Oh, thank you.
You're welcome.
Understanding. Understanding or comprehension questions are focused on the student's ability to use their knowledge to explain something. These questions demonstrate understanding. Comprehension questions start with words like compare, contrast, explain, give me an example, paraphrase, summarize, etc. Comprehension questions are necessary to determine if the student understands the information they have learned. This is critical when applying to learning in a real situation.
I'd like you to explain the difference to me between, say, a basic switch and one with a normal state.
Okay, well, basic switch, so like this toggle switch over here, can be left in either an open or closed position.
Right.
Switch with a normal state, however, has a spring in it. So when I'm not pressing the switch, the spring returns it to its normal state, and that can be either open or closed. And that's why we call it either a normally open or normally closed switch.
Good, good. Sounds like you got a good understanding of the difference between the naming of a switch and the state in which it's in.
Next 2 levels of questions on Bloom's taxonomy are application and analysis questions. Application questions are important for a student to demonstrate use of information in a new situation. Application questions start with words like apply, consider, and how would you. Application questions are important to determine if students can use information to implement change, adjust, or improve outcomes for a technical situation.
I see you've got a good understanding of how a control circuit works. How would you modify this circuit to control, say, a cooking process where a mixer would come on once a pot was full?
Yeah, well, I could add an upper float switch that would turn on the mixer once the pot is full. I would also probably add in a timer that would turn off the mixer after a certain amount of time.
Excellent. I like how you're applying that timer to shut the process down. It shows me that you're considering all of the steps throughout the sequence. Let's build it.
Okay.
Analysis questions are important for a student to demonstrate they understand relationships between several key pieces of information. Analysis questions start with words like what if and explain rationale. Analysis questions are important for a student to demonstrate understanding of information and accurate application to a new situation.
This is great. Can you demo this for me?
Yeah, hopefully everything works properly. Okay, so when the tank is full, I've set it up so that the timer controls the light and the light comes on for 1 minute. After 1 minute, the timer will shut the light off.
Okay, let's say there was a problem with the pump and it didn't shut off. How would you troubleshoot that?
Well, first I would check to see if there's a problem with the timer.
Let's expand on that. Can you give me a detailed explanation of why you check the timer first?
Yeah. The timer is the thing that's supposed to be controlling the mixer, so there's probably a problem with that.
Good, let's check the continuity of the timer contacts.
Okay, let's do it.
The fifth level of Bloom's taxonomy is evaluating. Evaluation questions are important for a student to demonstrate the ability to look back at a situation, accurately see the situation, assess the situation, and justify the results. Evaluation is a high level of thinking. However, humans are often forced to evaluate events in life out of necessity, most often when something goes wrong. Connecting this skill to real-life application is worth the time and effort. Evaluation questions start with words like appraise, decide, evaluate, and justify. Evaluation questions are important for a student to accurately look back on a situation, review the situation, and if necessary, re-synthesize or rework factors to get back on track.
Okay, let's evaluate this circuit. And we'll put an emergency override on the motor. How would you install an emergency override on the motor to shut the motor down if an operator wanted to do that in an instant?
Okay, well, I'd put a switch in series with the motor.
Okay, what kind of switch would you use? Would you use a toggle switch or one with a normal state?
I'd choose a toggle switch because it's for safety. I don't want the motor coming back on.
Nice. I like how you've included the safety factor. That's so important.
The final level of Bloom's taxonomy is creating. Synthesis questions are important for a student to demonstrate the ability to combine information and develop new structure or predict outcomes. Synthesis is a high-level skill, and students should demonstrate all other Bloom's taxonomy thinking prior to the challenge of synthesis questions. Synthesis questions start with words like create, generalize, plan, and predict. Synthesis questions are important for a student to demonstrate they can manipulate information and create a new strategy for different or unique situations appropriately.
Let's take a look at the circuit to see if we can modify it to add some more safety features. Can you predict any problems that may occur that we need to add safety features for?
Yeah, well, the motor could overheat if it gets stuck or overloaded for any reason. So I'd want to design some safety features into my circuit to account for that problem.
Okay, what kind of system would you add?
Well, I could use a couple things. I could either use a fuse, or I could use a current transducer, which would give me an overload signal, which I could use to drive a relay, and then that would shut the system down.
Nice, good revision, dude.
Thank you.
Can you draw that for me?
Yeah, for sure.
In conclusion, utilization of Bloom's taxonomy of learning will help the student improve thinking and application strategies. The student will develop clinical reasoning or technical savvy as they become accustomed to prediction and manipulation of information in new situations. The 6 levels of Bloom's taxonomy are remembering, that's the recall of knowledge or information. understanding, comprehension of information, and able to state it in their own words. Applying, using information to apply to a new situation either in the lab setting or in real life. Analyzing, determining the difference between facts and inferences. Evaluating, making judgments about the material or ideas. And creating new meanings, processes, or structures.